All right. What you're going to notice on my examples for factoring trinomials is that I don't start with the basics where the leading coefficient is 1. I start right away with a scenario where the leading coefficient is not 1, because if you get used to it always being 1, we make bad habits. So I'm going to start with the one layer up, one level up, where our leading coefficient is not 1. We have a 5. Because when we're working these problems, we have to be intentional about our magic X. The magic X always has to be A times C at the top and then the B value at the bottom. So when you have trinomials, it's always A, B, and C are the coefficients in the process. Now, it doesn't always have to be a quadratic, which is why I didn't write ax squared plus bx plus c, because this works for higher degree polynomials also, as long as they're trinomials in a quadratic form. So we want to pick up our a, b, and c and multiply our a and c here. Well, that's 5 times 16. So we get 80. And then we put 24, our b value, at the bottom. And this is a scenario where the top number is positive, which means either both the side numbers are positive or both of them are negative, and that's now guided by the bottom number, which we need a positive result. So both of these numbers are going to be positive and positive. So then we just have to figure out, well, what multiplies to be 80 that adds to be 24? Well, it's not 5 and 16. That would have been something we could have tried, but that doesn't add to be 24. So we've got to think of different numbers, and I'm seeing 20 and times 4 to get me 80. So I got 20 and 4. If you just, break the number down, you got 20 and 4, that gives you 24. And then 20 times 4 gives you 80. Sometimes there's little hints built in, sometimes they're not. Now, the key here is that these are my magic numbers. Now, the magic numbers mean that I can take this 24, this middle term, and I can rewrite it. So I'm going to take this 24 and I'm going to break it up into be two parts, 20x and 24x. So this middle term gets rewritten so that we have two parts to it. I didn't mean 24, I meant just 4. Let's try that again. So this 20 and 4 replace this 24 right here to become 20x and 4x. Together they make 24. But all the x did for me is identify how I could split up the 24 magically so that this problem will now factor with grouping. So if I bring this 5x squared up and this 16 up here at the same level, this is now a 4-term polynomial that is factorable by grouping. All the x does for us is it replaces the middle term with 2 terms so that I can now factor by grouping. So I'm going to write this up top now. 5x squared plus 20x plus 4x plus 16. And it shouldn't matter which order you put the middle 2 numbers from your x. It should factor with grouping one way or another. Just might have harder layers with negative signs with subsequent problems. But in this problem, it works out just fine. I look for my GCF between 5x and 20x, and I should get 5x. And when I divide my 5x squared by 5x, I should get just an x, because the x reduces out and the 5 reduces out to be 1. And then plus 20 divided by 5x should be 4. So my goal is on my grouping to work out to be my second binomial is going to be the same, x plus 4 there. But I recognize my GCF of 4 and 16 is plus 4. And if I divide my 4 and the 16 by plus 4, I get x. And then divide 16 by 4, I get plus 4. Sure enough, as I was hoping for, my binomials are the same. And so the grouping holds, and I can factor my x plus 4 binomial factor out. And what will be left, if I divide this x plus 4 out right here, x plus 4 divided by itself is gone. Now the 5x is left. And the same thing in the back one. Divide out the x plus 4, and that turns into a 1. And so the plus 4 is left. And now I have fully factored this trinomial. Using my magic x to replace the middle term, and then grouping. I call this the x group method. All right, so now we're going to do another one where we've got some negatives involved. So we've got our x off to the side, where we multiply the a times the c on top. And again, notice I'm picking examples where we've got an a value right away because we have to deal with it or we will forget about it. So 4 times 7, that's a negative 7. That's important. Negative 28. And then the negative 12 is your b value. It goes on the bottom. So negative 12. So this is a scenario where the top number is negative. So that means my signs here have to be at one's positive, one's negative. Doesn't matter which goes where, but I do need one positive, one negative in a way that adds to be 28. Well, 4 times 7 gives me 28, but adding it together gives me 11. So not quite 4 and 7. So I got to come up with a different set of products that multiplies to be 28 and adds to be negative 12. So 14 and 2 multiply to be 28. And we want the difference to be 12, but negative. So we need the 14 to be negative. 2 positive. That adds to be negative 12, and it multiplies to be negative 28. These are my magic numbers. Well, what are they magical for? They are magical because they replace the negative 12 so that this problem will factor by grouping. So I'm going to replace the negative 12 with negative 14x plus 2x. So essentially, I still have negative 12. I haven't changed the problem algebraically. I'm allowed to do anything as long as I didn't change it. And then 4x squared minus 7. The first and last terms just go up there. And so what's left, so this came from the magic, okay, right over there. I replaced that part. And now I'm just going to factor what's left with grouping. So I cut the problem in half. These both have if I'm looking quickly, a 2 and an x in common. So 2x. If I factor out a 2x by dividing out a 2x from here, that will reduce to be 2x. If I divide this by 2x, I'll get a negative 7. And then what you'll notice here is that the second term already is 2x minus 7. So be careful there. I know our eyes just say, oh, it's just 2x minus 7. But you have to actually factor something out. Well, if you're not factoring anything out, but you have to force factor something else, you have to factor out a 1. And so we're going to call that a positive 1 in common. Then parentheses, and you write 2x minus 7. I have to have parentheses appear here so that I can factor out my greatest common factor binomial of 2x minus 7. So 2x minus 7, I factor it out, and what's left, if I divide this by 2x minus 7, is the 2x. And if I factor the back part by 2x minus 7, anything divided by itself is 1, and that plus 1 is the result on that second part. So this is my fully factored trinomial where I figured out the magic numbers, replaced the middle term, and then factor by grouping, the x group method. All right, this problem, when I get my x going, I'm going to have a positive top term, 6 times 4, and the negative on the bottom. So my a times c is up top, and that's where I'm going to get 24. And then the bottom is a b value that's negative 11. So this time, 6 and 4 they give me the 24. They don't give me the 11, though. So I got to come up with a different set of factors that make 11. So I'm thinking 8 and 3. So 8 and 3 multiplied to be 24. Now, because the top number is positive, either these both have to be positive or both have to be negative, and that's controlled by the bottom value, which is negative here. And so I want that to be a negative 8, negative 3. These are my magic numbers. So I take them and magically replace the middle term to be negative 8x minus 3x. So negative 8x minus 3x replaces the negative 11. And then the rest of the problem stays the same, 6x squared plus 4. Just take the middle numbers to replace that 11. This still adds to be 11, so it's a legal algebra move. And then I factor by grouping. And the first two terms have a 2 and an x in common. And if I divide 6x squared by 2x, I should get 3x. Divide negative 8x by 2x, I should get negative 4. Now notice how that's very close to what I have in the second part. But I have a negative here, and this is positive. Well, everything's going to work out great if I factor out a negative 1 from there. And when we factor out a negative 1, we're actually dividing by negative 1. So when I factor out a negative 1, that's going to change my signs here to be a positive 3x, and divide this by a negative 1, and that'll get me a negative 4. So still doing my grouping technique here to make sure that my binomials are the same, and they are. So now I factor out my binomial, and I'll be done. 3x minus 4 is my greatest common factor. And when I divide the first term by 3x minus 4, that part cancels, and I have 3x left over. 2x I meant to say. And divide this second part by 3x minus 4, and I'll be left with my negative 1. That is my factored trinomial. Two binomial product of two binomials. If I multiplied it back out, I'd get the original polynomial, the original quadratic there. All right, our first example where we have a is 1. What's nice is we have the a is 1 times negative 12. So that product on top is just the negative 12. And then the negative b value, the negative 1 on the bottom, when we get to the end, things are going to be really nice. The factoring is very quick. So we have, to figure out what multiplies to be negative 12, adds to be negative 1. And so factors of 12 that have a difference of 1 is what my brain's running to. So we have 4 and 3 have a difference of 1. And one of the signs has to be negative, one has to be positive. In this case, we have the 4 needing to be on the negative, or the negative to be on the 4, so that when I subtract, I get negative 1. Now, when you do these problems, you do not have to go all the way through grouping if the a value is 1. You can write your factors to be x and the first number, so in this case x minus 4, times x and the second number, which is a positive 3. This problem is fully factored without the grouping process. This only works if the a value is 1. The magic numbers become the factors. What happens is students see so many of these problems that we think that whatever's on the magic x are the factored form numbers, and that's only true when the a value is 1. Now, you can go through the whole grouping process, but it will produce these two factors. Every time the a value is 1, this holds true. So do it this way. So to round out our examples with trinomials and the magic x, I want to make sure that we have our situation where it gets a little bit odd that our top number, the a times the c, is bigger than the bottom number. And that bothers some students because I get 2 times 1 is 2, and then on the bottom is 3. But usually why this is whenever the bottom number is bigger, it's just because you're supposed to use the top number and 1 to add to be the bottom number. So don't be stressed about it. Don't sweat it. It's just 2 times 1 gives you 2, and then 2 plus 1 gives you 3. And so we're going to go through the x group method here, where the 3x gets replaced by my magic numbers, the 2 and the 1. So it's going to be 2x plus 1x is what my 3 turned into. It's 2 things now instead of just the 1. And then my 2x squared is still in front, and my plus 1 is still on the back. And then the grouping process calls for you to cut it in half and focus on the left-hand side. These have a GCF of 2x. If I divide this by 2x, I get x. If I divide this by 2x, I get plus 1. And in the back, things look a little odd. You might look at that and say, well, there's nothing in common. Well, whenever there's nothing in common, quote unquote, it's actually a plus 1 that's in common. And so when I divide these by 1, it doesn't change anything. It's just x plus 1. But I need to see this plus 1 right here, because when I factor my binomial that's in common, this x plus 1 that's in common, what will be left is the 2x plus 1. So when I divide this by x plus 1, this part cancels and I just am left with 2x. When I divide this part by x plus 1, what'll be left is just the plus 1. And that is the result. Product binomials to be the fully factored form of this trinomial using the x group.